Hey everyone, so I wanted to make a separate video for the confidence intervals, just so it's a lot easier to find the different videos and techniques in terms of confidence intervals and testing. That way you can just click on the video instead of having to sift through a really long video. Okay, so where we left off was in this set of notes, just essentially how to do a test with a t-test. And in this case, this is going to be a lot more straightforward, and I'm going to be assuming that you essentially are already understanding the basic concepts behind a confidence interval. And so I won't spend a lot of time on the actual interpretation of it because we already covered that in class before, well, coronavirus. And so largely I'm just going to emphasize when you would use a t interval, an interval with a t statistic, and when you wouldn't. So the distinction again for, say, x bar plus or minus, you have your z star, and you have your sigma over square root of n. If you have your t, you have x bar plus or minus plus or minus t star s over square root of n. Okay? And so what I really like to notice and what helps me remember what I'm going to use is I look at what is going on with these two formulae aesthetically. Like I look at them like a piece of art. And if you look at them, you see that this is the same, this is the same, okay? But you see two differences. You see the one in the standard deviation and the sample standard deviation. And you also see t statistic, z statistic, right? So the biggest difference is, okay, why this? So why, oh no. Sorry, the pen died. Okay, so why let's see if I can, okay. Well, while the pen is charging, I'm going to pause this real quick and charge the pen. Okay, so sorry, we're back. Hopefully the pen is working now. Let's see. Okay. So, largely what we're noticing is we have this different t star and z star. So we have different critical values. Okay. And the reason we're not going to worry too much about this, one, is because they're fairly straightforward for all of you to compute, and also, two, because this depends on the table you use. Okay. And which table we're using will depend on sigma versus s. I'm actually going to draw that again in black. Sigma versus s. Okay. If you had some black and red lenses, you could get some 3D action going on there. But the main point being, if you are given a theoretical versus a sample standard deviation value, that's going to inform your selection. So if we have a sample, standard deviation, we're going to use the t. If we have a theoretical, we're going to use the z. Now, this one up here, we've actually already talked about how to do that, so I'm not going to go over that in this video. But the second one right here, we haven't talked about that yet, so I'm going to go over that. So I'm gonna erase everything. Let's throw our formula back up on the screen. We've got confidence interval. It'll be x bar plus or minus t star s over root n. So if we were to look at the example given above, okay, so I'm going to say from example above, oh, sorry, one sec. Oh, okay. So from example above, we know that x bar, say, is equal to 124.552. We know that s is equal to 12. And we know that n is equal to 16. Okay. So if we were to start setting this up, just using this confidence interval formula, okay, using this formula up here, we would have this so far, 124.552 plus or minus t star, okay? It'll be 12, and it'll be over the square root of 16, okay? Then, what we're going to do is we're going to go to our t-table. Give me a sec while I get that out. So we go to our t-table. Okay. I'm going to do a cute little representation of that down here. Let's do that. Okay, let's draw this cute little, get our little t-table again. Let's see what this thing looks like. Oh gosh, where is it? Now you all can actually hear me mumbling while I do things. Okay. Okay, we have the confidence level, which is what we're going to pay attention to. We'll have the one-side p-value, two-sided p-value. We'll have our degrees of freedom, okay? And what you'll notice is the confidence levels have levels from 50%, We're doing a 95%, so I'll just put the 95% interval there. And then it goes all the way up to 99.9%. Okay. And I'll just make that little representation right there. Okay. And the degrees of freedom, of course, goes from 1. I'm going to put 15 and 16, and it goes all the way up to 1,000. Okay. And so what you'll find, to get this t-star value, okay, we use the table. At n minus 1 degrees of freedom. So, n is equal to 16 implies that nu, or df, is equal to 15, which this again is just n minus 1. Okay. And so we go on our little t-table, we find 15. And if you go, and you'll see this confidence level part above, okay? So we'll see confidence level part above, we'll see degrees of freedom right there, and we're just going to find their intersection. 95% confidence interval, 15, and you'll find the value, let me do it right here, 2.131. You'll find the value, 2.131. And just an interesting note, if you look at degrees of freedom 1,000, and you look at the 95% confidence interval, you'll find 1.962, which close to z star for confidence interval at 95%. So what we found right here is this 2.131, and that's going to be our critical value, t star. That's it, you're done. No fancy doing anything. You just find your confidence level, find your degrees of freedom, boom. Now, there are a few cases that can happen. So first of all, I have to give you a confidence level that's on the t-table. So it'll be 50, 60, 70, 80, 90, 95, 96, 98, 99, 99.5, 99.8, or 99.9% on your on like quizzes and exams. Another thing that could happen is the degrees of freedom here only goes up to 30 before it starts skipping. And then it goes by tens, and once it hits 100, it goes to 1,000. So if we had, let me erase this. If we have, say, n is equal to 150, use on the table degrees of freedom equal to 100. And that's just because it's the closest thing we have to 150. I don't want you to go up to 1,000, not because it's so far away, but because it's essentially allowing for more degrees of freedom. I'd rather have you be more cautious and restrict it so you have fewer degrees of freedom. So if we were to say have n equal 990, I'd still want you to use degrees of freedom 100 because I don't want you to add those 10 extra degrees of freedom. So if you ever have to pick in between, just pick whatever's the safer bet, which will be the lower number. Okay, so just to finish off this problem real quick so I can give you a very precise answer. Confidence interval would look like this. 124.552 plus or minus 2.131 times 12 over the square root of 16. And that's your answer. And we're done.